Hi all, this is Guided Practice 2.4, and this is our 4.8 on Newton's method. So there's only one question here because this is just a very computational kind of thing, and I really just want you to be able to see how this is done once or twice. Okay, so remember that the formula that we're using for Newton's method is that your xn plus 1, meaning your next x value, your closer approximation, is given by negative f of xn over f prime of xn plus xn. So you're plugging in your previous x value into the original, then you're plugging it into the derivative, dividing those through, and subtracting it from your original x value. Okay, so this is what we're trying to do, right? We're trying to find a solution to the in the interval correct to 6 decimal places. So that means that our function here is going to be this thing right here. So your f of x is 3x to the fourth minus 8x cubed plus 2. And its derivative is 12x cubed minus 24x squared and no plus 2. Okay, now we need something in the interval from 2 to 3. If we plug the function in, plug 2 into our function, and I'm using a graphing calculator here. Let's see. If I plug in 2, I gotta adjust my calculator, to the original function, using your calculator, you're gonna get negative 14. So f of 2 is negative 14. F of 3 is 29. Okay, so now you can see there's got to be a 0 in between there because we're going from negative 14 when you're at 2 to positive 29 when you're at 3. And because our function is continuous, you can't jump over x equals 0. Or y equals 0. You're going to have to get y equals 0. Okay, so we want to find out at what x value does that happen. So what we want to do here is we want to choose a number to start with. Okay. Now notice that negative 14 and 29 are pretty far away from 0. It's not like 2 or 1. It's not like one is super close versus the other. We could try to choose one of those two as our endpoints. A lot of times I'll choose the first value. If you try to choose 2, when you plug 2 into the derivative, you're going to get 12 times 8 minus 24 times 4, and that turns out to be 0. So this is a similar one to the one we did in class where choosing that value creates a problem, right? We get the derivative equals 0, and so when we plug into our formula here, we're going to divide by 0. So we can't have that one. So 2 is not a good choice. If we plug in the 3, so let's do the same thing, only we've got 12 times 27 and 24 times 9. Subtract, we get 108. Okay, so I could start with 3, okay? But notice how negative 14 and 29 are kind of almost evenly spaced. So I'm actually going to choose the middle number, okay? Now, it doesn't really matter what you choose as long as you choose something within the interval that's not going to give you a 0 in the derivative, okay? Because we know that it's got to be pretty close to there. So I'm going to let my x equal to x1 be 2.5. So to find my x2, I'm going to use x1 in the formula above. So my x2 is going to be negative f at 2.5 over f prime at 2.5 plus 2.5. Now, the best way to do this is if you have a graphing calculator, you're going to plug in 2.5 and store button and alpha A. And then you're going to type in exactly what you see here. So negative parentheses 3 times a to the fourth minus 8a cubed plus 2, close parentheses, divide by, and then you're plugging your a into your derivative. So parentheses 12a cubed minus 24a squared, close the parenthesis, plus capital A. And if you do that, then you get 2.63. 6307. Now we want 6 decimal places, so 630725. So 2.630725. So now, to get our next one, we're going to take negative f of, and I'm just going to abbreviate here. I'm going to round it just for these purposes. We're going to use the exact value when we put it into the calculator. We're going to plug it back into that formula. So with your graphing calculator, all you have to do is with the 2.630724913 on your screen, hit store alpha A. That puts that new number into your A. Now hit second enter, and that brings up the equation that you just typed in, right? Your negative 3a to the fourth, yada, yada, yada. Hit enter, and it's going to give you your next value. So this value is 2.630020, 21, if I'm rounding it. Okay, now notice that we've got the same first 3 digits after the decimal place. So that means we are correct to 3 decimal places. So x3 is 2.630021. To get my x4, we're going to do the same thing, negative f of 2.63, right? That new number, and now it starts to matter more. I should be writing out more decimal places, but you know what I'm doing. Okay, so with my graphing calculator, store alpha A, and then we're going to second enter to get my function back, hit enter, and now I've got this. My x5, or my x4, is 2.63002025. Now we can see that the 5 digits now match, and we've just got to get that last digit going. So let's do it one more time. So you're going to do the same thing. So store alpha A, second enter, get your function, and now we've got this. X to the 5th is 2.63002025. And now you can see that we are correct out to, none of these digits are changing. 1, 2, 3, 4, 5, 6. None of those digits are changing. Even this digit hasn't changed, and this digit hasn't changed either. And therefore, we can be confident to say that to 6 decimal places, that the 0 is at x equals 2.630020. All right, because we wanted 6 decimal places. Okay. Now, I'll record another video where I will try to show you on the graphing calculator what buttons we push and how to make that happen.